Okay, so this is my pulley over here, and with this, I attach. मतलब देखते हैं इसके ऊपर क्या क्या अटैच करना है ना. So look over here. This is my pulley particularly, and पहले तो एक ब्लॉक ऐड किया, फिर दो ब्लॉक सिस्टम पे जाएंगे है ना आज. ठीक, मान लो अपन के पास कुछ इस तरह से मासेस ऐड है ना. ठीक, थोड़ा सा आज थोड़ा सा इसमें डेप्थ में जाने वाला है. मान लो ये 2 kg है और ये 3 kg है, और एक काम करते हैं, 1 मिनट रुक जाओ, सॉरी. इसको थोड़ा और बढ़ाते हैं, फिर मजा आएगा, फिर थोड़ा सा क्वेश्चन में डेप्थ में जा सकते हैं अपन है ना. तो मान लो ये 6 kg है ना, और ये 4 kg है. इज दैट क्लियर? तो एक 6 kg की ब्लॉक है, दूसरी 3 kg की ब्लॉक है, तो थर्ड 4th kg की ब्लॉक है. पूछा फाइंड द acceleration of the blocks. क्वेश्चन है फाइंड द एक्सेलरेशन ऑफ द ब्लॉक्स. क्वेश्चन नोट डाउन कर लिया तुमने? ठीक है, I'll open one book till that time. Okay. ठीक, आज मतलब थोड़ा ऐसा लगेगा कि पहले क्वेश्चन तुम बनाओगे, फिर तुरंत आंसर दोगे, फिर अपन आगे बढ़ेंगे. ओके, ठीक है. जल्दी से बनाओ. Last 2 minutes left. ठीक है, बनाओ जल्दी से. बना? Easy. There are, see, that's what I told you. There is no requirement of equations in these kind of problems. Learn the trick. Once again, this is 4G, and for that, just first I'll draw the tension. So here are two threads. So consider it to be T1. Once again, equal and opposite T1. This will be 3Z downwards, and then tension T2. Similarly, tension T2 and 6G downwards. Are you able to get me or not? Now look over here. If I consider basically this whole system will go down with same acceleration A or not, and this will go up with same acceleration because they are in the vertical plane and attached with each other. Are you able to get me? String needs to be tight. Is this clear or not? Yes. So the condition will be, so basically if I want to write the equation that day I told pulling force. So basically if I see this 4 kg combined with 3z will pull the whole system or not. So the pulling force becomes how much? 4g plus 3z. Are you able to get me? This quantity plus this quantity. Is that clear? Minus, if I look into that, opposing force is becoming 6g because all these tensions will get cancelled. So opposing force is 6g, and then how many masses are moving? 6 kg plus 3 kg plus 4 kg. Are you able to get me or not? Understood? So basically then acceleration becomes how much? 7g minus 6g, which is how much? Just g by 9 4 13. So g by 13 meter per second square. Is that clear or not? That's so easy. Are you able to get me or not? Now, if you know the acceleration, basically to calculate T1 and T2, it becomes too much easy. Like I can write the equations like T1 if I want to write the equation. So you look at the 4 kg block then. 4 kg is getting pulled by 4G or not? So 4G minus the opposing force tension T1 is nothing but 4 into acceleration A. Are you able to get me? Similarly, if I want to find the acceleration in T2, I can write the equation. Basically, the pulling force of 6 kg block is T2 minus 6G is equal to 6A. Are you able to get me or not? Yes. Basically, whenever the concept is same that whenever you want to treat something, treat it independently. Okay. Like I treated 3 kg block to be independently. Then I treated this 4 kg block to be independently. Are you able to get me or not? So when I want to write the tension equations, when I want to write the force equation, I have to treat the bodies as free body. And that's why we call it as free body diagrams. Are you able to get me or not? Yes. Okay. So these are the equations. Now, in the same question, do one case. Find the acceleration when we cut the second thread. Find the acceleration when we cut the second thread. Tell me what will be the answer. Both the any of the blocks. What will happen when we cut the second thread? All the blocks. Yes, that's correct. So basically, if I cut the thread, then what will happen? This thing, this basically whole thing, this tension T1 will be erased, isn't it? Yes. So when T1 will be erased, basically 4 kg, simply 4 kg will do the free fall. But then what we see here is still 3G is acting or not. But at that time, what has heavier? 6G is heavier than 3G or not? Yes. So what will happen? Basically, the yeah, the new acceleration will be 3G going up and 6G going down. So A will be what? Pulling force 6G minus 3G divided by how many masses? Two masses. 6 plus 3. Yes. So 3G by 9, which is nothing but meter per second square. Are you able to get me or not? Are you able to understand this? Okay. So we are going to bring another kind of problem, another kind of, okay, we'll come on this, but we'll do one more case of pulley system and then I'll move ahead. Okay. Then I'll include with the other cases and all. So look over here. Okay. Let us consider one thing. Let us consider that there are two pulley system which we usually do not do, but since you are even preparing for JEE little bit, I'll give you this thing. Okay. So let us think of one case that we have how to do it. Okay, let us do like this way. There are two blocks. Okay, once again, it should not become constraint relation. Let me check. Uh, okay, 1 minute. Let it be at center. Yeah. So now, so this is having three block systems. Okay, consider it to be mass m3, consider it to be mass m2, and then consider it to be mass m1. Now, find the equation of motion when m3 is greater than m2. Find acceleration of the blocks for this case. If Yeah, find the acceleration of the blocks. Pick up some questions. So yeah. Think once again. It's not. It's not that simple. Think once again. Okay, so how many threads are there? Two threads. So let us consider one thing. If this is M3Z and that is M2Z, okay, and this will be my M1G, isn't it? For this, the tension T, I consider it to be T. Are you able to get me or not? Yes. And now, if I look over here, if M3 is going, M3 is heavier than M2, so M3 will go down. Yes. M2 will go up. Now, when that is happening, look over this pulley. This pulley is a two, three threads pulley. So pulley will come down with some kind of average acceleration or not. Yes. So let us consider that at that time, try to let us make it through this. That let's suppose this mass M1 was going up with some kind of acceleration, and with that same acceleration, this pulley is going down. Are you able to get me or not? Okay, so look over here. Let's suppose if it is going up with an acceleration, how much? A naught. So pulley will also go down with acceleration, how much? A naught. But these two blocks, since these two threads are different, so these will have different accelerations, A and A. Are you able to get me or not? Understood. So basically, if I look over this scenario, this second pulley scenario, this is just like a lift in which there is a pulley. This is just looking like a lift where there is a pulley, and over here, basically the two masses are attached over here as M3 and M2, and this is my M3, where lift is going down with acceleration how much? A naught, and these bodies are doing their own acceleration A and A. Are you able to get me or not? Can I just visualize like this way or not? Yes. So basically, I'll write the equation for this lift case first, then I'll go to this particular first pulley part. Are you able to get me? Consider this to be second pulley part and that to be first pulley part. Are you able to get me or not? Okay. So look over here. If I write the equations now, as you know that any body in the now you look over there, since the lift has an acceleration, this is a non-inertial frame, isn't it? Non-inertial बन गया ना? तो जब भी हम मतलब जैसे बस वगैरह में बैठते हैं तो अपन फोर्स पीछे की फील करते हैं ना, जैसे ही बस आगे बढ़ने की कोशिश करती है कि नहीं, चाहे वो पार्टिकल कैसा हो, है कि नहीं. तो बेसिकली फॉर दिस एनॉट what will happen, these two both of the systems will feel a pseudo force, and both will feel the pseudo force in which direction? Upward direction. Are you able to get? Yes, is that clear? consider it to be, this is M2, so this will fill the pseudo force how much if I draw the free body diagram. So look over here. I'll draw the free body diagrams, respective free body diagrams. Okay, this is going to be a little bit huge equation. Don't take tension. So this is my M2, this is my M3. So for M2, as I have considered another, now this is thread 2. So consider it has different tensions. I consider it to be tension uh, T naught. If this was T naught, consider it to be T and T over here. Are you able to get me or not? So for mass M2, once again tension T upwards. First is tension T. Then it has pseudo force. Then it has its own weight. Are you able to get me or not? So this is my tension T. And then pseudo force m2 into acceleration, lift acceleration a naught, and then m2g, and then it is going with acceleration how much, a in the upward direction. Are you able to get me or not? Okay, similarly for m3, if I want to write its own weight downwards, yes, and then it will feel some kind of tension T in the upward direction, and then once again the pseudo force in the upward direction, but its acceleration is where, downwards. Are you able to get me or not? So m3 is tension T, m3 into acceleration a naught, and this is acceleration a, basically. Are you able to get me or not? So when we are going to write the equations, we can write the equations now of these two blocks. What is that? So there the tension is bigger, so tension T plus m2 into a naught minus m2z is equal to m2 into acceleration a. Are you able to get me or not? So for, if I want to write the equation for this block, but I will be ending, since it is going down, so m3z is having minus t minus m3 into a naught is equal to m3 into acceleration a. Are you able to get me or not? This is your equation or not? Understood? Totally? Yeah, so basically this is my equation now. What we can do is simply, basically I can write the equation now. Yeah, basically, but you will left out with one extra coefficient a naught or not. So basically, if I, yeah, so basically if I look over here, so if that is tension T naught, this is my also tension T naught or not? Yes. So can I write that tension T naught is nothing but twice T? On look over this pulley. Yeah, I'll tell you why. Look over here on this pulley system. Okay. If I look into this pulley system, the mass of this pulley is how much? Zero. What kind of pulley we are considering? Masses of the pulley are always equal to how much? Zero. We are considering massless pulleys. Are you able to get me or not? So when the mass of the pulleys are zero, then its acceleration is of no use. So upward tension must upward force must balance the downward force. Are you able to get me or not? Understood? So that's why we write tension T naught is equal to twice T. Are you able to get me or not? The mass. If you would have considered the mass, then definitely that term should have appeared. Equation should have been twice T minus tension T naught is equal to mass of the pulley into acceleration naught. Mass of the pulley. Is that clear or not? Understood? If we can see the third equation, look into the third equation, then we can write the equation that m here tension T is my, particularly T naught is my heavier term. So T naught minus m1g is equal to m1 into a naught. Are you able to get me or not? Now look over here. You got the equation of T naught. Yeah. So basically T naught is going to become m1 g plus a naught over here, and that is equal to twice t. So did you got your relation of twice t or not? Yes. So basically, if I look over here, I can establish the relation now. And when I am going to establish it, look over these two equations. Is that clear? So what you will be left out with is m2 a naught minus m2g plus m3z minus m3 a naught. This becomes a little bit huge, but no problem. And that is m1 plus m2 into acceleration a. Are you able to get me or not? Adding those two equations. Okay. So I can now look into the a naught terms. A naught common. That is m2 minus m3, and then once again minus g common, and once again it will become m2 minus m3, and that is nothing but m1 plus m2 into acceleration a. Are you able to get me or not? Yes. So basically you can utilize two or three equations. I can even replace 1 minute, 1 minute, 1 minute. We got a naught in terms of a over here, and that is a naught minus g m2 minus m3 is equal to m1 plus m2 into acceleration a, and that's what your equation comes over here, that a naught is nothing but m1 plus m2 into acceleration a divided by m2 minus m3 plus g. Are you able to get me or not? Understood? So we got our a naught over here. Is that clear? In terms of a. Is that understood perfectly? Yes. Now, if I look over here, then in any of these equations, I can replace all these equations. Okay, and then we can get all other terms. So, should I do the derivation or should I write the direct result? What do you want? Yeah, it will become a little bit huge, crowded equation, but or not. So, but no, I'll see. I have done one thing. I have written this equation. So this is my second equation. This is my first equation, and this is my third equation, and this is my fourth equation. Are you able to get me or not? Now it is your task to solve 1, 2, 3, 4. Correct or not? I have solved one a naught. Replace in any of these equations by a naught, and then put tensor t naught is equal to twice t. You are going to get the answer. Okay. So it's your task to little bit do it. Can you do it for me? Equations, correct. Basically, substitute in fourth, you will get the answer. Okay, so there is no need to substitute in third, but you can substitute in fourth, and then you will get the relation of A. Are you able to get me or not? Okay, so you can do that. Can you do that? No? Should I take your shot? You can do that. Try it. At least try it. Okay, at least try it. Okay, that's your homework. It's just a 10 minutes work. Okay, put this equation. Put this equation. Consider this equation as a star equation, and then put it in this fourth equation, and then in that replace the equation of t naught is equal to twice t. You are going to get the same value. Okay, or you can do one thing directly, instead of going through all these a naught, finding a naught and then replacing it. I just found out a naught because I was required to find the different acceleration of the blocks. Okay, so basically what I can even do is, see, this tensor t is related with t naught. Are you able to get me or not? So then also you can replace it with the particular twice t, and you can still replace it. Are you able to get me? T naught by half, you do it, you will get the same answers. Okay. So it's your task to do it. Is that clear? Okay. Try doing it, and then I'll tell you once again. Okay. Now, consider one more case. I'm just going to give you the different cases so that you can pick it up very fast. Okay. So for this case, consider it. Let's suppose here the particular monkey is over there. Okay, and he wants to means basically yeah. So I'll give you the question. The question is like this way. Okay, 1 minute. What question is saying is simple. A 12 kg monkey tries to uh, climb a light rope as shown in the figure. The rope passes over a pulley and it is attached to a 16 kg bunch of bananas. The mass and friction of pulley are negligible so that the pulley only affected to reverse the direction of the rope. What is the maximum acceleration the monkey can have without lifting the bananas? Yes. Monkey didn't have to lift the bananas, but monkey have to go up. Mhm. Basically simple. Monkey, you didn't understood the question. Let us read it once again. The monkey climbs a right light rope. What it is written? Climbs means it is going up. Okay. Yeah. So basically, he wants to climb up. He will go. So to climb up, he will have some acceleration, isn't it? Yes. So let us consider that it has acceleration how much? A. Then the question arises that what can be this value of maximum A? Means this A should be my maximum value in such a way that bananas which are kept over here should not lift. That the bananas kept over here should not lift up. That's your question. Yes, that's an it's a question which comes usually in your exams. अच्छा एक बात बताओ एक सिंपल सी कंक्लूजन बताओ अगर मोंकी ऊपर जाएगा तो रस्सी कहाँ जाएगी नीचे रस्सी नीचे जानी चाहिए ना लेकिन अगर रस्सी नीचे गई तो बनाना ऊपर उठ जाएगा ना तो रस्सी को कैसा रहना पड़ेगा अगर बनाना को नहीं उठाना है तो रस्सी को क्या मेरे को रेस्ट पे रखना होगा यस अगर स्टेशनरी रख पाए रस if I can keep the thread to be stationary then only the monkey will rise up isn't it yes so the you have got your answer tell me the answer now mm, think that's what so basically if the monkey does not want to basically whatsoever happens the since the thread is one so the tension will be same only T and T only isn't it and therefore here banana's weight is given so the tension will be nothing but 16 g finish I we have asked for the a max not tension yes now you tell me Mhm. No अच्छा ध्यान से देखो तो monkey weight is how much? 12 g. Look into the second part of this thread. This is my second part. Okay. If I consider the second part of the thread, if the monkey would have been at rest, tension T should be exactly would have been equal to 12 g or not. Yes. Now if the monkey now look at that imbalanced force. If there was no acceleration, then the banana would have been lifted definitely. Sorry. Then the monkey was never ever able to lift the banana. Are you able to get me or not? Now, if it has a acceleration, it is trying to pull that same thread with the same acceleration or not? Are you able to get me or not? Now, look over here. So, when the monkey is climbing up, for the thread is first balancing the weight of the monkey. Then, for the cheetah frame on the thread, the particular thread will particularly feel a pseudo force of mass of the monkey into acceleration A in the downward direction or not? Think. Simply, you just tell me one thing. It's not a kind of pseudo force. When the monkey is climbing up, where is my thread going? Downwards with acceleration. Now, if it is going downwards with the acceleration, you only think. Let's suppose if there is a 50 kg monkey and a 20 kg monkey, which one will pull the thread too much downwards? 50 kg or 20 kg? 50 kg. That means mass is affecting something or not? Yes, so basically what is happening? This acceleration in the upward direction is creating an acceleration in the thread in which direction? Downward direction. Are you able to get me? What? No, no, no. Why? See, listen. What is happening is we are considering for that particular point. The point is this is trying to pull the thread by acceleration A. Because if it is going with acceleration, the thread also must have acceleration A. Are you able to get me or not? But what is happening is, listen me, what is happening that due to this acceleration, the mass of the monkey and the acceleration may appears in the downward direction. Now, what is happening is basically this tension T over here is balancing this whole weight, the monkey's weight plus the monkey's acceleration, and that is why if these two tensions are becoming equal, the banana is not able to lift up. Are you able to get me or not? देखो एक बात बताओ एक सिंपल सी बात बताओ एक एक चीज पूछता हूँ तुमसे अच्छा मान लो ये एक बैलेंस्ड वेट है ठीक है ये बैलेंसिंग करने वाली एक वेट है ठीक और इधर मान लो मैंने 10 kg रख दिया और इधर सिर्फ 5 kg रखा बॉडी की टेंडेंसी कहाँ है जाने की नीचे है ना तो हाँ सॉरी 10 kg को नीचे जाना है 5 kg कहाँ जाएगा ऊपर तो मतलब अभी तुम इसके ऊपर एक्स्ट्रा फोर्स 5 kg का और रख सकते हो ताकि इक्विवेलेंटली बैलेंस्ड हो जाए जी ठीक करेक्ट तो ध्यान से देखो अगर मान लो मंकी के पास कोई एक्सेलरेशन नहीं था कुछ भी एक्सेलरेशन नहीं था ठीक है तो ध्यान से अगर देखा जाए पहले ये बात समझ में आ रही है क्या कि मान लो अगर ये थ्रेड हो गया सर सॉरी मान लो अगर ये आपके पास थ्रेड है और इस पे अगर एक मंकी चढ़ने लगे मान लो ये मंकी है ना ठीक तो मान लो ये मास ऑफ द मंकी m है ठीक अब ये इसके ऊपर चढ़ रहा है ओके तो ध्यान से देखो मान लो ये एक्सेलरेशन ए से ऊपर जाएगा कैसे जाएगा एक्सेलरेशन ए से तो ये थ्रेड को क्या करेगा थ्रेड को बेसिकली अगर ध्यान से देखा जाए तो अभी जो थ्रेड है वो एक्सेलरेशन ए से डाउनवर्ड जाना चाहिए है कि नहीं so then only it will be able to climb up isn't it यस तो बेसिकली अगर मैं थ्रेड पे देखूं तो थ्रेड के ऊपर फोर्स कितना पड़ा पहले तो पहले तो इस थ्रेड तो जो थ्रेड है वो मंकी का वेट को बैलेंस करेगा यस एम जी और जैसे ही मंकी के पास एक अकॉर्डिंग टू द थ्रेड अगर थ्रेड के हिसाब से देखूं मंकी के हिसाब से नहीं किसके हिसाब से देखूं सॉरी, थ्रेड के हिसाब से मैं बोल रहा हूँ, किसके हिसाब से नहीं देखना है तुम्हें, मंकी के हिसाब से नहीं देखना है। इफ यू लुक फॉर द केस ऑफ थ्रेड, then what will happen, this acceleration, and since this is a mass m, this will generate an another force in the downward direction or not. You can call it as a pseudo force. How is it? अच्छा, I'll tell you. Of course, it is an accelerating frame now. एक अब अभी तुमने पकड़ लिया, आधा पकड़ लिया, अब लास्ट बचा है। फिर से देखो, इस थ्रेड, अच्छा अगर मैं इस मंकी को हटा दूं यहाँ से, ठीक, मंकी चलना स्टार्ट हो गया है, मंकी को मान लिया एक ब्लॉक है, मंकी क्या अभी, मंकी ब्लॉक नहीं है, मंकी अभी हटा दिया, तो इस थ्रेड के ऊपर मास कितना प्रेजेंट है, एम, है ना, है, प्रेजेंट है या नहीं है, उस मास एम के वजह से एक वेट आएगी या नहीं आएगी ओरिजिनली, आएगी। मंकी कहाँ जा रहा था एक्सेलरेशन ए से ऊपर, अभी थ्रेड कहाँ जा रहा है नीचे, अगर मंकी के वजह से मंकी ऊपर जा रहा है तो वो एक एक्सेलरेटिंग फ्रेम हो जाएगा, तो उसके अंदर पार्टिकल कहाँ जाएगा, एक्सेलरेशन ए से नीचे, लेकिन उस थ्रेड के ऊपर मास कितना प्रेजेंट है, एम, तो इसके वजह से थ्रेड का मास नहीं है उसमें, जो मंकी प्रेजेंट जो अपना इफेक्टिव मास दे रहा है उसको मान रहा है, आर यू एबल टू गेट मी और नॉट, तो वो जो मास एम ए नीचे आएगा या नहीं आएगा, सोचो जरा, मतलब, हाँ, तुम सोच रही हो कि सर थ्रेड के ऊपर तो मास ए में ऊपर जाना चाहिए, ऊपर लगना चाहिए, लेकिन एक बात बताओ, थ्रेड तो नीचे जा रहा है ना, यू गॉट इट, यू डू नॉट नो, टेल मी। I'm coming on that, wait, okay, now look over here, so you got the idea that ma will be downwards or not, due to the relative acceleration, are you able to get me or not, अब ध्यान से देखो, अगर मान लो इस पर्टिकुलर मंकी के पास एक्सेलरेशन होता ही नहीं, कुछ भी एक्सेलरेशन नहीं होता, तो देखो अगर ध्यान से देखो, तो अगर कुछ भी एक्सेलरेशन नहीं है तो मंकी की वेट कितनी है नीचे, एम जी, 12 जी, है ना, एंड दैट शुड हैव बीन बैलेंस्ड बाय माय टेंशन टी, यस। अब ध्यान से देखो जरा, एक बात सोचो, इधर 12 जी है, इधर 16 जी, तो एक्स्ट्रा एक्स्ट्रा टेंशन क्या स्टिल मींस, अगर अगर मैं इधर की तरफ in on the left side if I still make till 16 g, till that time the particular banana will never ever move, no, मैं मतलब अगर डाउनवर्ड फोर्स को जब तक 16 जी से ऊपर नहीं लेके जाऊंगा, बनाना ऊपर उठेगा क्या, नहीं उठेगा। तो तुम्हें मालूम है कि अगर नीचे की फोर्स को बढ़ाना है तो मंकी को कहाँ चलना होगा, ऊपर चलना होगा ना, तो वो एक पर्टिकुलर ऐसे एक्सेलरेशन से जाएगा ताकि नीचे की फोर्स 16 जी से बड़ी हो ही नहीं पाए, तो उतने एक्सेलरेशन रेंज तक चलता जाएगा या नहीं चलता जाएगा, सच दैट द पर्टिकुलर द थ्रेड विल बी एट रेस्ट और नॉट, समझ में आ गई बात, तो उस एक्सेलरेशन की वजह से उस थ्रेड के ऊपर वो फोर्स लगा रहा है, वो थ्रेड को मूव नहीं करा पा रहा है, आर एबल टू गेट मी, got it, now you got it. So what is ma, ma is not its acceleration, thread is not moving, thread is visualized to be moving but it is still at rest, are you able to get me, thread is not moving, but force present रहेगा, but force present रहेगा, हाँ, but the force will be still present, are you able to get me or not, ऐसा ही होगा ना, अब बात समझ में आई। अब मान लो किसी किसी चीज को, देखो एक तो ऐसा हो गया कि पहले तो मतलब मंकी ऊपर जाना चाह रहा है, तो ऊपर जाएगा तो एक्सेलरेशन एक के साथ जाएगा, तो तुम खुद सोचो ना, अगर मंकी जब प्लांट्स के ऊपर चढ़ते हैं तो प्लांट टूटता क्यों है, क्योंकि उसमें टेंशन बढ़ जा रही है कि नहीं, टेंशन बढ़ किस वजह से रही है? तो एक्सेलरेशन जितना तेजी से चलोगे उतना देखना प्लांट झुकेगा, है कि नहीं? हाँ, तो वो क्यों हो रहा है? क्योंकि ज्यादा जोर से चलने से वहां जो पार्टिकल्स है, पार्टिकल्स जो अटैच्ड है वो एक एक्स्ट्रा एक्सेलरेशन फील कर रहे हैं, और पहले से जो मास प्रेजेंट है एम है, उसके वजह से एम है, उसके वजह से जो जनरेटेड फोर्स होगा डाउनवर्ड डायरेक्शन वो कितना हो जाएगा? एम ए हो जाएगा। आर एबल टू गेट मी और नॉट? जैसे मान लो अगर एक पर्सन है, एक पर्सन ऐसे वॉक कर रहा है, ठीक, तो बेसिकली अगर मैं ध्यान से देखूं तो ये ग्राउंड पे फोर्स कितना लगा रहा है? एम जी। लेकिन वॉक कहाँ कर रहा है? फॉरवर्ड डायरेक्शन में कर रहा है ना? Are you able to get me or not? That's what is happening over here. The monkey is walking, but look over there. As it is moving, let's suppose if it is going to move with F force in the forward direction, he needs to balance it by friction F same by same amount of force or not, so that he must not fall. Are you able to get me or not? So this is your confusion. Okay, that the although the monkey is moving with acceleration A, if the value of tension does not exceed 16G, the thread will never ever move. So that is why it is told that find the maximum value so that the banana will never ever lift. Are you able to get me? So basically on the other side, second side tension becomes how much? Maximally MA max plus mg. Are you able to get me or not? Which is nothing but 12. You can write 12 a max plus g. Are you able to get me? Equate it, 16g is equal to 12 a max plus 12g. So it is 4g by 12 is equal to a max. Are you able to get me or not? That is nothing but 40 by 12 meter per second square. Are you able to get me? Understood. Totally. Ask me. For what? Try to imagine. Try to ask. If you clearly visualize this, then look over here. What is actually happening? I'll show you. Basically, the monkey is attached with the thread, isn't it? Monkey is hanging off the thread. So when he was at the rest, he was pulling the thread by equal to its weight, so that the thread will never ever break. That was exactly equal to how much? Mg. Till the monkey is in on this thread, wherever is on this thread, this Mg is working. That we know. Are you able to get me or not? Yes. Now, as the monkey is climbing up, look over there, the particular acceleration by which he will climb, he will try to pull this thread downwards with a similar acceleration. It is trying to pull. It is not sure that it is moving it. Are you able to get me or not? Are you able to get? Then only he will be able to climb up with the acceleration A or not. Now the monkey, the attached mass with this thread was m only, isn't it? Because the thread mass was how much? Zero. So look over there, mg was already working. Then due to this acceleration, the net force that will be developed on the thread will be ma plus mg or not? Because the attached mass on the thread is how much? M. Are you able to get me or not? What will happen? That will become the normal case. If it is that will become to this particular. Yes, it is only working for living things because it is trying to go up. Yeah. Okay. Is that clear? Totally. Okay. So basically, this is the way you can understand it in a much more perfect way. Is that clear or not? Okay. Now we can make it hard, but that will be once again a question for you. Try that same thing. The whatever thing you were asking, I'm just making it a little bit difficult for you. that this is my pulley, okay, and on one side there is a thread, on the other side there is a block of mass m, take, and from this side a particular monkey is trying to climb up, which has mass 2m. How much is how much it has mass? Consider it, yeah, 2m basically. Are you able to get me or not? Then, if the question arises that if the monkey climbs up with an acceleration, how much? A naught. If the monkey wants to climbs up with an acceleration a naught, लिख लो. If the monkey climbs up with an acceleration a naught, then find the acceleration of a small m. Is that clear? Okay, so it's a task to do. I'll check it later. Okay. Yes. Two homeworks given. Okay. Okay. Now let us come to the one more case, which we also call the system of inclined planes. Sorry. Which we also call the system of inclined planes. Okay. And then we'll see what is going to. Okay. So let us take the first scenario. Okay. Now look over here. On this system, I attach two blocks, and this is my block M. Okay. And this is my block 2M. And this inclination is theta. Then find the acceleration of block. Tell me what will happen. Okay. Mm, acha, basically for the M, I'll resolve it, isn't it? So this is mg towards this side. It will be how much? Mg sine theta. This will be mg sine theta. And then I'll have, since the thread is one, this will be tension T, this will be how much tension T, and this will be twice mg. Are you able to get me? So this will go down with acceleration A and this will go up with acceleration A. So equation becomes twice mg minus tension T is equal to twice ma, and this becomes T minus mg sine theta is equal to मास इंटू एक्सेलरेशन. पता है बहुत लोग क्या करेंगे ना, इधर भी mg sin थीटा लिख देंगे नहीं, इधर मास इंटू ए होता है, मास इंटू इट्स एक्सेलरेशन. दिस इज राइट साइड, यू हैव टू टेक द फोर्स इक्वेशंस. आर यू एबल टू गेट मी और नॉट? Yes. So basically what will be my equation? Twice mg minus mg sin theta is equal to thrice ma. ध्यान से देखो. Got it or not? So basically m got cancelled. G common, twice minus sin theta divided by 3 is my acceleration of the blocks. Are you able to get me or not? Put this acceleration anywhere, you will get the particular what tension. Is that clear or not? ठीक है. तो अब ऐसा भी तो हो सकता है कि इसमें दो मतलब डिफरेंट डिफरेंट इंक्लाइन प्लेन आ जाए. ठीक है. सो इफ देयर आर डिफरेंट इंक्लाइन प्लेन्स लाइक, look over here. It's visualizing as equilateral. Let us decrease it, as you said. It's always getting equilateral. Okay, so no problem. This is my diagram. Okay, now I attach a pulley over here. Okay, with this I attach two blocks, mass m1, and this side mass m2. Okay. Now the question arises is simple, that if m2 is greater than, and this is theta 1, well this is theta 2. Okay, and this is my theta 1. Okay, the question is simple, find acceleration of blocks if m2 is greater than m1. Then find the acceleration of the blocks if m2 is greater than m1. uh, Tell me what would be the accelerations. So here we have once again one thread now. Okay, so m2 will go down with acceleration a while m1 will climb with same acceleration a, isn't it? Does the thetas are same? Correct. Okay, can I say that this will be m1g and for that one component? Yes, this will be m2g and for that there will be one component, isn't it? Look over here. So if this is theta 2, it will carry the component of theta 2, that will be m1g sine theta 1, and for that tension T is in upward direction. Are you okay? Just do one thing, just a little bit erase it. Consider it to be same coefficients. It will give the clear view. Okay. So this is theta 2 and this is theta 1. Okay. So that is my m1g sine theta 1 then. Now for m2g, this will be what? m2g sine theta 2. Are you able to get me or not? And same tension T. Is that clear? So basically equation will become what? Since m2 is bigger than m1, so the pulling force is m2g basically, this side. So equation will be what? m2g sine theta 2 minus tension T is equal to m2 into acceleration A, and this will become tension T. For mass m1, T is my pulling force, so T minus m1g sine theta 1 is equal to m1a. So what you got as an equation? Solve it. You will get as m2 minus m1, sorry, it will become m2 sine theta 2 minus m1 sine theta 1 divided by m2 plus m1 into gravity g is nothing but my acceleration. Are you able to get me or not? Understood now? Totally? Okay then. Now let us do one little bit intriguing case. And till now we didn't considered that the thread used to have masses. But this time we are considering, let us suppose the thread has mass m and the mass of the block is m, and then I pull this whole system by a force F. Then the question is, find the tension in the middle of thread. आज मैंने तुम्हें बहुत अच्छे अच्छे क्वेश्चन कराए है ना. Let's suppose the length of the thread is given L. In the middle of the thread, that is L by 2 basically only, no? Tell me. Achha, how to do it? Basically, if I look once again, then the whole system is getting pulled by forces, so whole system will have a common acceleration AC or not. As you know that thread cannot be loose. Shruti, sorry, Srishti, are you able to understand me? So the acceleration will be what? Force by capital M plus small m. Are you able to get me or not? Now, I want to ask you find the tension in the middle of the thread, isn't it? So how you are going to do? Look over here. Basically, then if I ask you from anywhere now, then you just do two things. First, take the block, attach the remaining part, which will be attached with the block. ओके मतलब जितना देखो जैसे L by 2 से पूछा ना, तो ये जो L by 2 है ना, यहाँ पे इसको कट कर दो. क्या कर दो? कट कर दो, है ना. तो ध्यान से देखो तो बस इस फ्रंट वाले L by 2 पे फोर्स F लगेगा, है कि नहीं? यस. यस. सो अब जैसे ही फोर्स F लगेगा तो पार्टिकल टेंसिटी अप्लाई करेगा या नहीं करेगा? और इसका एक इक्वल एंड अपोजिट रिएक्शन होना चाहिए ना. अब देख, अब ध्यान से देखा जाए तो बेसिकली ये जो लेंथ है वो कितना है, L/2 है एग्जैक्टली exactly, और ये लेंथ कितना है, है ना। अगर L/2 है तो तुम खुद सोचो जो मास होगा वो M/2 और M/2 में डिवाइड होगा या नहीं होगा, हो जाएगा। ये और ये बड़ा वाला मास कितना था, कैपिटल है। तो बेसिकली अगर पूरे सिस्टम के पास कॉमन एक्सेलरेशन AC है ना, मान लो ये कॉमन एक्सेलरेशन इसका AC, तो इसका भी तो कॉमन एक्सेलरेशन AC है ना, जरूर। तो बेसिकली इस होल M+M/2 को फोर्स F थोड़ी ना पुल कर रहा है, क्या पुल कर रहा है, टेंशन T। तो क्या मैं लिख सकता हूँ, टेंशन T इज इक्वल टू M+M/2 की कॉमन एक्सेलरेशन AC which is nothing but M/2 plus capital M into common acceleration AC is nothing but F by M plus small m. Are you able to get me or not? Got it. So equation of tension becomes what? That is nothing but M plus twice capital M divided by M plus capital M into F by 2. This is my tension T which will be present at the center of the thread. Are you able to get me? So the first step was what? Finding the common acceleration. Second step was dividing it from where it is asking, and then write the mass of the each part of the thread. Then one of the tension will definitely pull the backside of whole the system combined with the common acceleration AC, and that is my tension of the thread. Are you able to get me or not? ठीक, तो इसका एक एडवांस वर्जन कर लें अपन, है ना। मान लो सेम क्वेश्चन है, ब्लॉक attached with the thread is getting pulled by force F. This is mass M, and this is a small m having length how much, L. Find the tension at 3L/4 distance away from block. Good. बताओ क्या होगा। The first step is what? Finding the common acceleration AC, isn't it? Common acceleration AC will be how much? Force F by total mass which is getting pulled M plus small m. Are you able to get me or not? Now it is asking 3L/4 distance. So this will be my 3L/4 distance away from my block or not. So बचा हुआ डिस्टेंस कितना होगा, L/4 बस, है कि नहीं। तो सेकेंड स्टेप क्या होता है, इसको डिवाइड कर दो पूरे सिस्टम को। तो दिस इज गेटिंग पुल्ड बाय फोर्स है, उसका एक टेंशन टी लगेगा, और सिमिलरली एक इक्वल एंड अपोजिट टेंशन टी लगना चाहिए या नहीं लगना चाहिए, बताओ, है ना। और ये लेंथ कितनी है, 3L/4, ये मास कितनी है, कैपिटल एम, और ये कितना, L/4। तो इस पार्ट का जो मास होगा वो M/4 होना चाहिए या नहीं होना चाहिए, और इधर सिंस मास इज डायरेक्टली प्रोपोर्शनल टू लेंथ, 3M/4। आर यू एबल टू गेट मी और नॉट। तो मैं बोल सकता हूँ ना कि इस पूरे सिस्टम को ये जो टेंशन टी है वो कॉमन एक्सेलरेशन एसी के साथ खींच रहा है। तो मैं लिख सकता हूँ ना दैट टेंशन टी इज नथिंग बट M+3 into स्मॉल m/4, ठीक है, into कॉमन एक्सेलरेशन। ये बना या नहीं बना। तो इस इन दोनों क्वेश्चन से क्या समझ में आया कि अगर मास आ जा रही है तो हर पॉइंट पे अलग अलग टेंशन होगा या नहीं होगा? होगा ना। तो इसीलिए इसको बोलते हैं, दैट्स व्हाई व्हेन वी हैव द masses in the thread, the every point experiences the different different tensions, and that is why we call it that as an example of variable tension. क्या बोलते हैं इसे अपन? Are you able to get me or not? So we did so many things. We did these things today. Still, there are many things we did completed till this particular term. Tomorrow, I am going to teach you. Right now, after this, I'll take a doubt class. Okay. So tomorrow, I'll be completing this spring plus division of masses. Evening, evening, evening. हाँ हाँ 9 p.m. 9:15 p.m. Okay, tomorrow. Is that comfortable? Huh. So we'll do division of basic objects and spring cases tomorrow. Are you able to get me or not? Division of basic objects will help you in center of mass, rotational mechanics and all those kind of things. Okay. ठीक है, स्प्रिंग कंप्लीट करके फिर अपन सीधा एक बार फ्रिक्शन पढ़ लेंगे और सबका एक बार कंबाइंड क्वेश्चन कर लेंगे। आर यू एबल टू गेट मी और नॉट? कॉन्फिडेंस बिल्डअप हो रहा है? ऐसा क्वेश्चंस पहले किए थे क्या तुम? नहीं ना। लेकिन इसी तरह के क्वेश्चंस आते हैं एक्चुअली में नीट में। और कुछ क्वेश्चंस कर लेंगे और इसको कंप्लीट करेंगे 3 से 4 और 2-3 लेक्चर में। आर यू एबल टू गेट मी? Okay, okay, so I'll finish this and then I'll clear your doubts. Okay.